Okay, so greetings, and welcome to Eureka Math Squared. This is grade 6, module 3, lesson 12. And today it's all about reflecting points or ordered pairs in or on a coordinate plane, which is pretty cool and not such a difficult concept. So what we're actually going to do is not begin on page 149. We're going to cruise on down to the exit ticket here, hanging out. This is page, what page is this? 151. Page 151, okay? And I'm going to teach you everything or show you everything you need to know right on this coordinate plane. Okay, so first of all, what I like to do when I first deal with these coordinate planes, ordered pairs, is I love to put in my quadrants. Okay, so this guy here is an x value is a positive, y value positive. This guy over here, quadrant 2, is a negative x value and a positive y value, right? Because we're going left and up. This guy down here is quadrant 3, and we have two negatives here, a negative x value and a negative y value. And quadrant 4, we have a positive x value and a negative y value. Just helpful stuff when we're dealing with things, all right? So reflecting points, all right? So we are what is called reflecting today. And reflecting has the word reflect, like a mirror, and that's really what we're doing. So if I have a point over here, let's say this guy right here, and this is ordered pair, x value is a 2, and the y value is a 4. Okay, notice both positive values, quadrant 1, and I decide to reflect this point, let's say over the y-axis. Okay, if I'm reflecting over the y-axis, what I'm doing is I want the same distance from the y-axis on the other side of the actual axis. In other words, if this is 2 units away, right, on the right side, then I want that same point 2 units away on the left side. There you go. Okay, now those are the worst brackets ever, but I think you get the idea that I want the same distance from that actual axis. So if I'm reflecting over the y-axis, I want that same, well, not the same point, but I want a point that's on the opposite side of the axis, but the same distance from the axis. Okay, and so what is that actual point? Well, watch what happens here. If I have a ordered pair 2, 4, that is now an ordered pair negative 2, 4. And notice the difference. I went from a positive x value to a negative x value. And that's one of the fun things that you can pick up in your brain there and stick in your head, that if you reflect, right, reflect over the y-axis, comma, right, the x value, right, is opposite, right, becomes the opposite, right? So if it's a positive 2, it becomes a negative 2, okay? Now I bet you can guess what happens if I then reflect over the x-axis, right? So if I want the same distance from the x-axis, but on the other side, I count 1, 2, 3, 4 away. So 1, 2, 3, 4 away, but on the other side, there's my point. Okay, so 4 from this side, 4 from this side, and now my ordered pair, well, that changes as well. Except this time, my x value stays exactly the same, but my y value becomes the opposite. Okay, so there's that rule number 2, okay, that if I reflect over the x-axis, right, because that's what I just did, comma, the y value is opposite. Okay, there you have it. All right. And so at times they'll say, or someone will say to you, hey, what if we reflect over both axes? Right. Well, if you do, well, guess what? Let's say this is my starting point, and I reflect over the x and then over the y. Oh, excuse me, over the y and then reflect over the x. I'll probably wind up right about there. But as far as the ordered pair is concerned, well, guess what? From the original, both x and y value will then become an opposite, right? So if I start with a positive 2, that'll become a negative 2. And if I have a positive 4, that'll become a negative 4. Now, if you do wind up reflecting over both the x and the y, the x and the y and the x, you do wind up in the same spot, right? It doesn't matter. So if you reflect over the x-axis first and then reflect over the y, that's the same as saying, hey, why don't I just reflect over the y first and then over the x? You wind up in the same spot. Okay, so that's the deal, folks. Really wasn't that much if I were to check out what's actually in this exit ticket. They gave me a point, right? This guy right here. So this is ordered pair 8, comma, -2. And they ask you to reflect over the x-axis. That's this guy here. So I'm going to wind up right over there. And I know from my little rules here that if I reflect over the x-axis, my y value becomes an opposite. So, or my ordered pair, right? So my x will stay the same, but my y value, which was a -2, will then become a +2. And then if I take that same point and reflect over the y-axis, that means I wind up way over here, right? Same distance, right? Same distance from that actual axis. And I know that if I reflect over the y-axis, then my x value becomes the opposite. So if I have a +8 to start, that'll then become a -8, but my y value will stay exactly the same. Okay? And then if I reflect over both, okay, and if my starting is an ordered pair 8, comma, -2, let me just write it again over here, that would then become the opposite in both cases. I would have a -8 and a +2, and that's where it'll land. Let's see if that's true. There it is, a -8 for my x value and a -2 for my y value. Okay. Oh, +2. Wait, what happened there? Should be a, oh, I only reflected once. I had to reflect over twice, so I wind up over there. There it is. So my -8, comma, -2, +2. See, I made a little mistake over there. It's a good thing I used my rule. There it is. Okay, so reflecting once, reflecting twice. There you go. All right, so that's the deal. I hope you enjoyed that. And math rules, folks. Take care. So long. Bye-bye.